Today's lesson is congruent polygons. I'm going to scoot up a little bit. There. All right, congruent polygons. Polygons are closed shapes, triangles, quadrilaterals, pentagons, hexagons, polygons. Congruent, this is the symbol for congruent. Congruent means equal in every way, exactly equal. Quadrilaterals have an inside angle sum of 360, and triangles have an inside sum of 180. So we have already worked with triangles, and I just want you to remember quadrilaterals have 360. And then if we're talking about congruent polygons, then they have corresponding parts, and corresponding parts are also congruent. And we're going to be working with that today. So if you have corresponding parts, that means it's the same place in a different shape. So it's the same exact place, just in the other shape. Sorry, those are corresponding parts. So, example 1, let me scoot you over. Copy that down. Quadrilateral HJKL is congruent to quadrilateral MNPQ. Now, when they are lined up like that, you can see the corresponding parts are going to be in order. So, angle H and angle M, since they're lined up, those are the corresponding parts. So, H and M will be congruent. L and Q will be congruent. So the question says, name all corresponding parts, angles, and sides. So let me show you how to do that. First, we'll start with the angles. We already talked about angle H is congruent to angle M. So those are corresponding. Angle J corresponds to N. Angle Q corresponds to angle P, and angle L corresponds to angle Q. So those are all the corresponding and congruent angles. The side measurements are going to be very similar. The way they are lined up is how they're going to be congruent. So the segment HJ is going to be congruent to the segment MN, but we can see it on the picture. So we'll talk about this segment right here, this segment HJ, and you write a line segment with a line over it, is congruent to MN. JK is congruent to NP. Line segment HL is congruent to MQ. And if you want to check, then come up here and look. You see HL is MQ. So they're always going to line up. And then the last one, I haven't done KL? KL is congruent to PQ. So those are corresponding parts, corresponding angles, and corresponding line segments, and corresponding parts are congruent. So let's do some examples. More examples. Oops, sorry. All right, write that down. Example 2. Triangle ABC is congruent to triangle DEF. Find the value of X. So I have two triangles and they are congruent. If you see ABC, DEF, that's the way the order is written. So that kind of gives you a hint to the corresponding parts. Angle A is going to be congruent to angle D. It's asking us to find the value of X. So here's our expression, 3x minus 11, and that is angle D. Well, we know that angle D corresponds to angle A. So what is the measurement of angle A? Well, we know that this whole triangle together is 180. And this is 90, and that is 35. So we can do 180 minus 90 is 90, minus 35, and that's going to give us 55 degrees. So A is 55 degrees. That helps us figure out what X is, because now I can set up an equation. D also has to be 55 degrees because it's corresponding to A. They're congruent. So that means 3x minus 11 is going to be equal to 55. So I solve that equation, and x is equal to 22. If you want to check, you plug 22 in for x, and then you simplify this expression, and you get 55 degrees. So this is an example of how to use congruent polygons. right, sorry, I'm moving the computer. Example 3. All right, example 3. Copy it down. The triangles are congruent. Write an equation and solve to find x. So we need to write an equation and then we need to solve the equation to find x. I have 2 congruent triangles. RST is congruent to WXY. So I know that R is congruent to W, corresponds to W. So R and W, S and X, and T and Y. So I need to find the value of X. I have 2 X's. I have an X here and an X here. So let's start with first one. We'll start with W. Angle W is congruent to angle R. I'm just setting up my problem. Angle W is congruent to angle R because these are corresponding. That means W is 12x plus 14 equals 62 degrees because angle R and angle W are corresponding, and that means they're congruent. I can solve this equation. Subtract 14 on both sides and you get 48, and x equals 4, right? 4 times 12 is 48. So that's one of the x's. Now I don't know if the other x is 4. We'll see. So this one, x is 4. Now let's work on this x, ST. So line segment ST is congruent to line segment XY. And I can see that because ST right here and XY are in the same place. ST is 3x minus 9 and XY is 15. So now I have an equation and I can solve it by adding 9 to both sides. Plus 9 is 24. Divide both sides by 3 and x equals 8. All right, so 2 separate x's in this one. One of them you had to use corresponding angles, and the other ones you had to use corresponding side lengths. All right, let's do another example. All right, example 4. Polygons ABCD is congruent to polygon PQRS. In this example, I want you to find x and I want you to find y. To find x, angle A right here. Angle A is congruent to angle P. Do you see how I'm using the position and my ordering? You might get confused and think it's R, but it's actually angle P. So angle A is congruent to angle P. Well, I know that angle A is 2x plus 4, and angle P is 100. Now I have an equation. I can solve that equation by subtracting 4 from both sides. 2x equals 96, and x equals 48. And then if you want to try it and test it out, you plug it in. 2 times 48 is 96. Plus 4 is 100. Now, over here for y, it says find y. So here's y, is DC. So I'm going to start with DC. And I look up here. DC is congruent to SR. And I gave you both measurements, so you have to figure out which one to use. And so you want to use this one, SR. DC is 3y minus 3. And SR is 12. Now, again, we've set up an equation and we can solve it by adding 3 to both sides and then dividing, and y equals 5. All right, so this is a very quick video on congruent polygons, and we will practice more in class.